Hello everyone. Today I will be explaining a simple but very useful image processing technique called gray level slicing. This method is mainly used to highlight specific brightness region in gray level image, such as in medical X-rays, satellites, images and industrial scans. By the end of this presentation, you will understand why is it useful and how it works mathematically and how it can be implemented using a small Python code. In many grayscale images, like X-rays or satellite photos, all the important areas often appears with a similar brightness level. Because of that, it becomes difficult to clearly see the parts that really matter, like bones in X-ray or water bodies in satellite pictures. Gray level slicing helps solve this problem. It picks a certain range of brightness value and makes them stand out so that the important areas become clearer and more visible. For example, in medical imaging, we can highlight bones or tissues. In satellite imagery, we can focus on water bodies or land areas. In industrial inspection, it can help. Let's now understand the simple math behind it. Every pixel in a grayscale image has brightness value ranging from 0 to 255, 0 as black and 255 as white. In gray level slicing, we select a specific range, say from R1 to R2. To apply a rule, if a pixel value lies within that range, we make it bright. If it's outside the range, we either keep it as or make it dark. This means we are enhancing a certain portion of the image, making hidden details visible. It's like putting a spotlight on a specific brightness zone while dimming a rest. Now let's look at where this technique is actually used. In medical imaging, it helps isolate bones, tissues, or tumors to help doctors focus on the key areas. In remote sensing, we can separate vegetation, water bodies, or urban areas in satellite data for environmental monitoring. In quality control, factories use it to detect defects or scratches on surfaces. And in object recognition, it can highlight specific part of an image to make machine learning models identify object more accurately. So even though it sounds simple, gray level slicing plays a big role in making image analysis more effective. For this, here's the Python code used to perform gray level slicing. It uses two libraries, OpenCV for image handling and NumPy for fast mathematical operations. The code reads a grayscale image and defines two values, minimum value and max value, which are the brightness range we want to highlight. For example, 100 to 120. The important line is np.where image greater or equal to minimum value and image less than or equal to max value. This line means if the pixel value is between 100 to 180, make it white. Otherwise, keep it unchanged or make it black. This logic runs on a pixel at once. Make it very fast and efficient, even for large medical or satellite images. Let's look at the results. On the left, we can use the original image. It looks dull and flat with low contrast. In the second image called with background, the target brightness range is highlighted but the rest of the image remains visible. This helps when we want to keep the overall context. In the third image called without background, only the selected brightness region is visible and the rest is made black. This is useful when we need to isolate a feature completely. The transformation clearly shows how gray level slicing enhances visibility and helps us focus on the important part. To summarize, it's simple to apply, mathematically precise, and practically very useful in many fields like medicine, industry, and research. So that was all about gray level slicing in image processing. Let's quickly look at the key takeaways. First, selective enhancement. Gray level slicing helps reveal hidden details by isolating specific brightness region. Second, mathematical precision. It works on pixel level intensity, creating sharp and focused visual improvements. Third, practical implementation. With Python and OpenCV, it's simple, efficient, and easy to apply in real world projects. And finally, improved interpretation. By enhancing contrast and highlighting target regions, it helps us understanding and analyzing images much more efficiently. Was all about gray level slicing in image processing, a small but powerful method to make hidden details visible by enhancing specific brightness level. Thank you for listening.